In this video, I'm going to be explaining what altitudes and perpendicular bisectors are, and then we'll practice identifying them in diagrams. So an altitude, let's start with that. An altitude is a segment that extends from a vertex or comes from a vertex and is perpendicular to the opposite side. So it's going to intersect at a perpendicular intersection, or it's going to be perpendicular to the joining side. It's going to look different depending on the type of triangle. For acute triangles, I can draw all of my altitudes inside the triangle, and we can get it to extend from a vertex and be perpendicular to the opposite side. But for a right triangle, I can only do that at one vertex. So I can draw an altitude right here and be perpendicular to the opposite side. But in order to draw the other altitudes from the other vertices, I'm actually using a side of the triangle. So in order to be perpendicular to this side and come from this vertex, this altitude is actually the side of the triangle. And the same thing happens down here at the bottom. I have to come from this vertex and be perpendicular to the other side. The only way I can do that is to be this side of the triangle. In obtuse triangles, it gets even crazier. I can still only draw one altitude inside, but if I want to draw another altitude coming from a vertex perpendicular to the other side, I have to draw them outside the triangle. So here's one example. If I draw an altitude from this vertex in order to be perpendicular to the opposite side, the only way to do that is to draw the altitude outside the triangle. So the altitudes may look different depending on the type of triangle, but they're always going to come from a vertex and be perpendicular to the opposite side. Perpendicular bisectors are slightly different. They're going to be a segment that bisects a side of the triangle and is perpendicular to the opposite side. So they're different from an altitude in that they don't have to come from a vertex. So in order to draw a segment that's perpendicular to this side, bisecting or intersecting at the midpoint, I can't draw it from a vertex, and that's okay. It's just a perpendicular bisector as long as it's perpendicular and bisecting the opposite side. So perpendicular bisectors are going to intersect at a midpoint, and they're going to create two congruent smaller segments there. It is possible, however, to be both an altitude and a perpendicular bisector, as long as the segment is coming from a vertex, intersecting the opposite side at a perpendicular intersection or 90-degree angle, and bisecting that opposite side. If it does all three of those things, we can call it both an altitude and a perpendicular bisector. So we can really have four situations. A segment can be an altitude, it can be a perpendicular bisector, it could be both, or it could be neither. So looking at these examples, we're going to focus on segment AB in each of these triangles and try and classify them as one of these or both or neither. So looking at this triangle, segment AB is coming from a vertex and is perpendicular to the opposite side. That's the definition of an altitude. In this triangle, segment AB is coming from a vertex, is perpendicular to the opposite side, and is bisecting that opposite side. So it's a perpendicular bisector, and it's an altitude because it came from a vertex. So it's both. In this example, segment AB is coming from a vertex, but it's not perpendicular to the opposite side. So that's not an altitude, it's not a perpendicular bisector, it's neither. In this example, segment AB is coming from a vertex and is perpendicular to the opposite side. That's the definition of an altitude. Let's do a couple more. In this example, segment AB is perpendicular to an opposite side and is bisecting that opposite side. So that's the definition of a perpendicular bisector. In this last example, segment AB is coming from a vertex, vertex A, and is perpendicular to this opposite side. So even though it's the side of the triangle, it's also an altitude. So hopefully that explains and helps you identify altitudes and perpendicular bisectors.